All right, this is the last two sections in Unit 4 dealing with matrices. You've got this assignment this week, as well as a small matrices quiz online. It's trying to give you a little bit easier type of summative assessment to help your test grades if you needed that. Most of you don't need it. On your quiz, it's untimed, and you've got 2 attempts. You've got help me solve this, and you've got view an example in case you need it. All right, in 12.3 and 12.4. Sure, yeah. All right, in 12.3, 12.4, we're looking at determinants of matrices, inverses, and solving systems of equations with matrices. And everything kind of builds on itself. Like you need a determinant to help you find an inverse and so forth. But the only thing special, or well, one of the things that are special about it, only a square matrix has a determinant. What makes a matrix a square matrix? So a square matrix, of course, is where it's going to have the same number of rows as columns. Same number of rows as columns. So of course you can have a 2x2, 3x3, 4x4, and of course the larger the dimension gets, the harder it is to find your determinant. So, but today we're going to focus on a 2x2 and a 3x3. All right, let's say you have matrix A. When you see the notation for determinant, this is what it looks like. They'll say find the determinant of A, or they may show vertical bars instead of the bracket. So if you see either one of those, that means find the determinant. All right, determinant of 2x2, very simple. You're simply going to multiply, and you don't have to write it again. Just going to show you the process. You're going to multiply diagonally from the top left to bottom right first. And then you're going to multiply from the bottom left to the top right. So that'll give you negative 20. And the last thing you do with these is subtract. So just cross multiply and subtract your two numbers. So the determinant of A is what? Yes, you can. It's 23.
So is that like when it's a system of equation, when you find that to solve it?
When it's a system of equations, we're going to use like all of your coefficients and put them in a matrix. And I'm going to show you how to type it in a calculator online to solve it. There's really the other way for solving systems with a matrix is doing what I just said, like putting all their coefficients, which you're gonna see that in a minute, and then using what we call Gauss-Jordan elimination. And you have to change, like, it's long and tedious, and we save that for pre-cal. You'll do that next year in pre-cal. All right, questions about a 2x2? All right, next thing is a 3x3 determinant. Okay, let's say we have matrix B. Okay, your first step when you're finding 3x3 determinant, you take these first two rows and you rewrite them out to the side, out to the right every time. First two columns, I think I said rows, but it's the first two columns, you rewrite them out to the right. Okay, in a similar manner to a 2x2, what we do from this point is diagonally multiply. Where did we start in a 2x2? Good, we started top left and went to the bottom right. So we're going to do the same thing in a 3x3. And you can do this in your head as you go. I know some of you can do that, and that's perfectly fine. So I'm going to show you what I'm talking about there. So let's say I have to start at 4 and I have to diagonally multiply all the way to the bottom. So 4 times 3 times 1. What are your next three numbers that get multiplied? You go this direction all the way down until you reach the very bottom right number. Yes, you multiply all those numbers and add them all together. Okay, this is from your first, the direction going from top left all the way 3 times to get to the bottom right. And it will always be 3 values that you're adding together for that first part. So multiply, and you could just, of course, write your product down here and say that's 12, negative 12, 2, and then add those all together if you wanted to do that. It's perfectly fine. Okay, now let's look at the second direction. What did we do with our two numbers that we got for different directions here? Subtract it. So you're going to have a minus sign. All right, we're going to start at the bottom left. And we're going to multiply this way. Yeah, until we reach the top, what? What number will we stop at? 6. Okay, negative 1 to 2 to 4. And then 1, 2 to 6. Yes.
So I'm like that. one right out? Like,
No, that's what I was just saying. You do not have to write this out. I'm just showing you like where it all comes from. But if I were you, this is what I would do. Like I was, so I'll write it a little bit bigger so you guys can see it. But I would just write the products underneath like 4 times. Yeah, and then this one would be -12 when you multiply those. Right, and then 2. And then what do you do with those numbers? Good, you add all those up. So what do you get there? 2. And then you can do the same thing up top. Like this product is going to be what? -3. And then this product, -8. And this, 12. And then you're going to add those up to give you 1. And then you just have to be careful what order. Make sure you always subtract this number that you got from those bottom. What? 2. So you should get the determinant was 1. All right, which numbers are you talking about?
the one that doesn't, it's like a 2 and 3.
2 and 3. 2 gets taken care of here.
Oh, I see.
Yeah, and then 3 gets taken care of here. All right, we'll do another one quickly and I'll show you without writing all of that. I think it'll be a little bit better on you. But just in case, I've got some people that like to write it all out and be very thorough and detailed. All right, you guys do this one, this next one. Do I need to leave this up? Is anybody still writing? Okay. Yes. Yes, it does. Make sure like the sum of the products you get from going top left this way, that number goes first.
Okay.
Hey, did I get -10? You got what? Okay, let me double check. Alright.
I think one of this supposed to be going on.
Oh, yeah, it is. Thank you.
When do you want?
Yeah, that's an 81. I tried to fix it. It will not let me write on flat out. Okay, how do y'all, is this a lot better this way without writing it all out? All right, do y'all have any questions about a 3x3? What'd you say? Yeah, sure. Yeah, you can't, they won't let you exit out of it, I don't think. Is it making your computer restart in a certain, yeah, yeah. All right, we're gonna, determinants, one more thing about them. They may, of course, reverse it and actually give you the determinant value and then ask you to find a missing element of your matrix. It's 22. Oh, sorry, 2.2. All right. So, of course, just recall what you know about a determinant. Tell me how you might set this problem up to solve for X. How did we find, well, let me back up. What do these vertical bars mean? If it is a matrix, but it's kind of like the absolute value of matrices. It means what? Determinant. So if you see vertical bars and not brackets, that's telling you to find the determinant of that part. You are. It's just an element in that matrix, though. You have to use the determinant. All right. Anyway, how do we find the determinant of a 2x2 to begin with? Good. We multiplied across, so I got 5, and then minus. Good. Minus -2x, and that is equal to what? They told, good, 22. They told you that the determinant value is 22. So when you use the determinant process, set it equal to 22. Then just go through and solve. What are your 2 steps to solve for X? Good. Subtract 5 and then divide by 2. So you get 17/2 or 8.5. There you go. That's exactly what I was. Just the nearest even number to 17, 16. All right, anybody have any questions about this? All right, now that we are familiar with determinants, let's look at inverses of matrices. All right, there's two conditions. Either a matrix has an inverse or a matrix does not. And you use the determinant to figure that out. If you calculate the determinant of your matrix, let's say we got matrix A, if that determinant comes out to be 0, it has no inverse. If the determinant value is 0, it does not have an inverse. If your determinant value comes out to be anything other than 0, then it does have an inverse. So that's the very first thing you check. You have to check determinant. If it's 0, life's easy for you. You say no inverse and move on. Here's your formula to use to find A inverse. You would say 1 over your determinant value. So find determinant, and then you're going to make a fraction with it. All right, I'm going to go back up here. Let's say I had a matrix A out to the side and it had elements A, B, C, D. When you're finding its inverse, you take that 1 over determinant value or that fraction and you multiply it to these elements, but they're switched. So you have to switch A and D. A and D switch places. B and C's signs change. So switch from top left, bottom right, and then just simply change the sign of those values. And then you multiply that fraction to everything inside, and you'll have your inverse matrix. Okay, this example, does B have an inverse? If so, let's find B inverse. All right, what's the first thing we have to check? Good, we got to make sure the determinant is not 0. So determinant of matrix B, multiply this way, subtract, multiply that way, and get positive 6. So my determinant is negative 15. So does it have an inverse? Yes, it does. So let's move on. All right, I have to take 1, you don't have to write this, but I have to take 1 over determinant B, which is 1 over negative 15. And we are multiplying that to the matrix we get when we, what are you doing with these numbers? Good, you're gonna switch places with those. And then what are we doing with -6 and -1? Good, so they both become positive. And then I have to multiply. This is where it gets gross. Typically, and when you're finding an inverse of every matrix, you're gonna be multiplying by a fraction. So just distribute -1/15 to every number. So -1/15 times 3, what does that become? Good, -1/5. -6/15 become -1/15 times 6 becomes -6/15, which reduces to what? -2/5. What are your numbers on the bottom row? -1/15 and +1/5. The main things I see students make a mistake on is just they forget to switch, change signs, and then they forget to multiply by 1 over -15 instead of just that. Okay, any questions about how to find an inverse? Okay, let me ask you guys, how do y'all feel about, let's say I went over multiplying matrices with your class, with the other half of your class Friday. How do y'all feel about multiplying matrices? Kind of good, iffy? What'd you say?
I forgot what I got on that.
The only reason I ask is because in this 12-3, 12-4 assignment, they ask you about multiplicative inverses. Multiplicative inverses. They're going to ask you, are two matrices multiplicative inverses of each other? And all you have to do is multiply your matrices together. If your answer or result is an identity matrix where you have ones along your diagonal from top left to bottom right, and zeros everywhere else in the matrix. If this is your answer, then yes. If you don't get that, you say no. That's a 3x3. Of course, for a 2x2, it would have ones here and zeros here. And of course, for a 4x4, ones all the way to the bottom right, zeros everywhere else.
Is the inverse the same for the 3x3?
Finding the inverse, we're not going to do that because it is a lot different, and it would probably take at least a whole page to do. Yeah. We say pre-cal does that. Actually, right now pre-cal's on matrices too, and they're having to find. It's almost like Gauss-Jordan elimination in a way, but you guys will see what all that is next year. So just be thankful you only have a 2x2 to find the inverse of right now. And you should not have any questions that ask you to find an inverse of a 3x3. All right, next thing, we got 2 more small topics to talk about, and then we'll be done. In 12.1 and 12.2, bless you. In 12.1, 12.2, we looked at how to solve matrix equations that only dealt with addition and subtraction. Today, you're going to have to find an inverse, then multiply. So if you're still kind of iffy on multiplying matrices, it's blended in with these examples. All right, your matrix equations are going to look like this. Let's say I've got some matrix A multiplied to some matrix X equals some matrix B. How would you, of course, solve for X? You would divide by A. There's no such thing as matrix division. So we have to multiply by its inverse. So instead of like dividing by 5, what's another way you could do that? You'd multiply by what? 1/5. So you're going to get matrix X by saying A inverse times B. So all of this is built when we looked at determinants. You have to find an inverse. Then in this part, we have to find an inverse matrix first, then multiply it to another matrix. So a good bit of work when you're solving an equation, and you have to do that. I feel like this has been the longest week, and it's like only Tuesday.
It's only Tuesday.
I think, right? Yeah. All right, we've got this matrix multiplied to X, and of course, we cannot divide by a matrix. So we need to find the inverse of the matrix with X, and then we have to multiply it to this matrix. Be very careful about order. Notice up here, I wrote A inverse first. So make sure when we find the inverse, we're going to put it before this one to multiply. All right, what was our process to find the inverse? You need to check what? Good. So let's find the determinant of it. What is it? Remember, multiply that way, then multiply this way. What'd y'all get? 1. There you go. 10 minus 9. So 1. So we're good to go. Determinant's 1. It makes it easy on you in the next part. Exactly. So you're multiplying by 1/1, which is 1. And what do you do with these elements? Good. Switch those. What do you do with 3 and 3? Change the sign, and then 1 times all of that stuff. So our inverse matrix is that. Okay, last step, we take that matrix and multiply it to the other matrix, 1, -3. Do you guys remember how to check and to see if you can multiply matrices? There's something you have to check. What's your dimensions or order of this? This is a 2 by 2, and this is what? Be careful. It's there you go, 2 by 1, row by column. So it's got 2 rows, 1 column. As long as these inner numbers are the same, they will multiply. What should the dimensions of your answer be? A 2 by, it's the numbers outside. So that's kind of a way you can know if you did it right at the end. All right, let's begin this long process. You always multiply by taking every row in the first matrix, multiplying those numbers to every column of numbers in the second. So when I take this row of numbers, 2 times something plus -3 times something, this is the way I do it. I'll always write this first row of numbers out across however many times I have columns in my second. So I only had one column, so I just write that row of numbers out, and you always put a plus because you multiply and then you add those products. So let's do the same thing with the bottom row. We only got one column, so I'm going to write -3, put a blank to fill in, plus 5 times blank to fill in. And then you just go back and fill in with that first and only row of numbers. So 1 goes here, -3, 1, -3. To me, that's just a lot easier than trying to keep up with like 2 times 1 plus -3. And then when your matrix, especially when your matrices are bigger. Okay, so multiply and add, we're done. What do you get for that top? What are both your numbers? 11, -18. And that's matrix X. And we said that it should be a 2 by 1, and it is. So the math involved in this is, it's not hard, but it's it's long, can get long. All right, you guys ready to see the last part? Final part of the day? I know, there's one more part. I feel like this lesson goes on and on forever. Does anybody still need that? Yeah. Okay. What'd y'all say? I know. That's what I'm thinking. That dryer has been going on forever. Somebody's making sure their hands are very dry. All right, in unit 3, you guys just got finished solving systems of equations. You solved 2 equations, 2 variables, and you solved the awesome 3 equation, 3 variable systems I know you love so much. Not really. I'm going to show you how you can use matrices to solve systems of equations using a calculator instead of doing it by hand, which we'll do next year in pre-cal. Because there's a reason. There's always a method to our madness, but by making you guys know it both ways. I mean, most students plan on taking further math like calculus and beyond. So you'll see it again in those areas. And if you don't plan on taking calculus, then you'll never see it again past pre-cal. How many of you, do y'all know what you want to do yet in college? At least, yeah, some general ideas. Okay. All right, I posted the link to this in your Schoology folder for 12.3 and 12.4. So it's in there for you. We're gonna go over one example and then we'll be done. All right, you can go to that website, and when you get to that website, which I'm going to show you what to type in a second. Okay, the first thing we're going to do is create what's called an augmented matrix using the numbers that are in this system of equations. Take your coefficients of x and 2. So you have 1, +2, and then there's a bar inside an augmented matrix, it separates what the equation is equal to from the coefficients of the variables. So you've got 1, 2, what will be your bottom row of numbers?
5, 7,
Good, 5, 7, negative 13. Now, one thing that you have to be very careful of, notice that 1 and 5 are associated with X. So if you start with the values of X at the top left, you need to make sure they follow that column all the way down. So make sure that always make sure your variables are on one side, constants all on the other, and all my X and Y's are on the left side, all my constants are on the right, so we're good there. And in order. So make sure if you put X's in the first column, you do that all the way down, Y's in second, all the way down. So fill in zeros for anything missing. So let's say that all I had in the second equation was 5x equals negative 13, then you would have 0 where Y is at, or where 7 is at. So fill in zeros for missing stuff. All right, your goal, if you were solving this by hand, using what's called Gauss-Jordan, you would have to get ones along your diagonal and zeros everywhere else, and you would have to perform what's called row operations to do that. So you'd have to multiply row 1 by negative 5, add it to row 2, get your new matrix, move on, and keep doing that until you got all these numbers be 0 and 1. So goal, your answer will look like this. And you'll have some numbers out to the right. Okay, you're gonna see rows and columns, of course, of boxes. So all you're gonna do is take that first row of numbers 1, 2, and then I'm gonna leave this blank because I don't have a third variable, and I'm definitely gonna leave this blank. I didn't have a fourth variable, and I'm gonna set it equal to negative 5. Do the same thing here, 5, and then positive 7, leave this blank, set it equal to negative 13. And of course, you leave the bottom 2 rows blank because you didn't have a third equation, fourth equation. Then you're going to scroll down and you're going to select solve by Gaussian elimination or Gauss-Jordan, and scroll down, and there's your answer. So what is, and X is going to be 3 and Y is going to be negative 4. And I'll show you why that's the case. So I told you that if you were to do this by hand, and they actually show you that process on the computer, but it's confusing. You would have 3 in this spot, and you don't have to write this down. You'd have 3 here and 4 here. And how you know that X is 3, remember I told you if you're gonna list the numbers associated with X on that first column, the only place where you see 1 is at the top. So you go across, that's X. In the second column, the only place to see 1's here, go across, that's Y. All right, are y'all okay with that? Since you guys wish I would have shown you how to do that when you're in chapter 3 with all of those systems and equations. Okay, work on your Math Excel.